my favorite new tool of the last 3 or 4 years or so, Microsoft's Visual Studio Code. It's a free IDE essentially for writing code, and I've used it to write and maintain SQL, Python, HTML, CSS, JavaScript, just about everything that I need to do.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Mike Dalbo. He's been on the show before. Last time he was giving us insights into how he got involved with geospatial and what his career path has looked like. And this time around, we're going to try something new. This time, we're going to walk through a case study of what I would think would be a pretty typical GIS geospatial problem to solve. So I hope you find it interesting, and I'm really looking forward to your feedback on this one because it's something I'd like to do a little bit more of, but of course only if it's something that you would like to hear more of. So please, I'd really appreciate your feedback on this. Just before we get into the interview with Mike, I want to thank our sponsor, OpenCageData. So OpenCageData is a geocoder. And up until recently, I actually thought or made the mistake of assuming that geocoding was a solved problem. That, yeah, there's lots of geocoders out there, just grab one and off you go. Turns out this isn't the case. Geocoding is not a solved problem. It's not an exact science, and it's a pretty difficult problem to solve. OpenCageData does a fantastic job of solving it. They don't do anything else, they do geocoding, so they're completely focused on it. They provide amazing service, and I have been fortunate enough to work on a few different projects with Ed, one of the founders of the company, and it's been a fantastic experience. I cannot recommend them enough. Hi Mike, welcome back to the show. It's an absolute pleasure to have you on again, and I'm saying welcome back because you've been here before. In fact, we published an episode on the 27th of November 2019, and that was called Don't Just Make the Dots, Connect Them. And I really like that because that gave the audience, I should say, a look into what the world of GIS or geospatial is like when you're out there working in the industry. And we're going to take a similar approach today. We're going to be using this interview as a case study. But before we dive into all that, just to give the audience some kind of background here, could you give us a brief overview of the situation? Who are you? What's your job title? And who are you working for? What sort of problem are you trying to solve?
Yeah, no problem. And thanks for having me. Again, my name's Mike Dalbo. I work as a GIS coordinator for a department in the state of Minnesota. Everything I mentioned today is my views, of course, not the state of Minnesota's, but my job working for the Department of Education is primarily to manage spatial data and connect it to other data systems in order to administer programs that affect various education programs throughout the state. So school districts in the state of Minnesota are completely independent. They operate on their own budgets, their own systems, and so on, but they get aid from our department with things like administering federal funding programs, for example. So my job is to make sure that everybody knows where the schools are, where the libraries are, where the school districts are, and that sort of thing. And this case study that we're going to be talking about is basically an annual update of all those schools and school program locations, the attendance boundaries that affect those, and the district boundaries that those individual attendance boundaries make up. So the district boundaries essentially encompass the attendance boundaries, or you could think of the attendance boundaries as nested within the district boundaries. So really, very basic, classic GIS data management, a lot of point and poly information. If you're out there just getting started in GIS, or you're working for a different sort of vertical, you could kind of think of this as maybe stores in sales territories, or facilities that are inspected by various inspection territories or something like that. So, I'm going to be talking a lot about schools and school districts here, but this type of information, this type of case study can apply to a lot of different situations.
Yeah, cool. I think you did a really good job of sort of setting the scene a little bit there. Perhaps we could go a little bit deeper now and say, what are we going to... So I think we understand we're going to be updating some data. Could you tell us how is this data going to be used? What's going to be the effect of these updates? Why does it even need to be updated? And then I think we can sort of start walking through the case study from there.
Yeah, absolutely. So this data is used both internally and externally. So Internally within the Department of Education, it's primarily used to administer funds for federal lunch programs or federal sort of food programs run basically by the Department of Agriculture. And I believe the Department of Education, the federal Department of Education, is involved. So it's basically making sure that those funding mechanisms get distributed fairly, equally across the state. So there's all kinds of spatial challenges out there for folks externally. For example, the Department of Agriculture is a place where I used to work. I know that when a pesticide spill happens out there in the world, and folks hope that that doesn't happen, but it does happen. If a school is nearby or within a certain distance, that spill gets ranked higher in terms of the risk of population exposure because kids are more vulnerable to exposures like that than adults. So that's just an example. So I know lots of local governments use the data to help look at challenges in transportation, to validate what their own records are on school district boundaries and things like that. So there's a lot of different uses, both externally and internally, of this data.
Okay, so I mean, obviously, you said a whole bunch of important things there, but a couple of things that really stuck out in my mind, having been in a similar situation before, working as a geospatial consultant, was that external and internal parties need to see this data. So immediately in my mind, I'm thinking there's some kind of web service involved, but I mean, obviously, there's other ways of distributing data, but that would be a go-to thing for me. So put the data in a database, make the join, and distribute it through a web service. Was this an option in this particular use case?
Yeah, and not just an option, but actually an expectation. So, one of the things I want to make clear today during this, especially as we're talking about this specific topic, is that I think you mentioned earlier, just because there's one way to do something doesn't mean it's the only way. And my predecessor was somebody that is very well known in our community, even won a lifetime achievement award. He just retired. And so the big shoes to fill there, right? For me, and also big expectations. He did his work really well, did it in a slightly different way than I did it, but the end result is published shared data, both in file-based format and service format. We have this thing called the Geospatial Commons, which is something that I've worked on for years, and I'm very proud of. And it's a single place for people to go and get spatial data in Minnesota, and it's very well put together. Data is well documented. Not everything is shared as a service, but quite a few things are shared as services. So I'm doing both, and I can tell you more details about how I did that a little bit differently and how it looks now.
Yeah, and I think it's always interesting when you start a project like this, and there are those sort of upfront expectations where people, okay, last time we did this, it looked like that, and people want to see the same, if not better, again from you. At least I'm assuming. So there's a few different expectations there. So maybe we could talk a little bit about, give people an overview of the architecture, because we talked about publishing a service, and you talked about having the information available as files as well. Could we talk a little bit about the architecture and then maybe dive into some of the database magic that you did?
Yeah, absolutely. So, from an architecture perspective, what we have for tools available to us is primarily Microsoft SQL Server is the primary backend. That source of truth database that I talked about, we could call it the organization database. It's on SQL Server. The GIS data is on SQL Server as well, unfortunately, in kind of its own silo in a way, but merging the two is not difficult with SQL. So there's some good structures in there that really make this job a lot easier than if it was just entirely siloed or entirely in file-based situations. We're lucky, of course, that we have Esri's ArcGIS server that can connect to that backend and produce web services. And then we have this Geospatial Commons as our portal for discovery. We also have access to ArcGIS Online, and here's one of the things that I did a little bit differently to meet those expectations is my predecessor shared the services on our internal or our sort of locally hosted ArcGIS server services and just sort of told people to use those and go and run. And that was publicized. And when I looked at that, I said, okay, there's a couple of issues there for me. One is I don't know what the usage is going to be when I just tell everybody to just go have at it. And so I'm not sure I can support that long run sustainably alongside supporting all my own programs, all my own applications, and so on and so forth. What I did was I said, I'm going to take this yearly update of these three main layers: school programs, attendance boundaries, and district boundaries. And I'm going to take these three layers and I'm going to load them into ArcGIS Online as a single report, a single year's cut, so to speak, and make them into feature services there. The data is not that big. I don't think any single data set is more than half a gig or something to that effect. We're talking, when we talk about school programs, we're talking 5,000 records, right? Not a huge data cost for that data hosting, but then I can I can advertise those services. I am advertising those services and telling folks to connect to them. And I can let Esri's architecture, in the cloud scale as necessary with the ups and downs of the demands there. So that's different. I'm leveraging that platform there. Because it's a single upload, and then I really don't get charged for the usage, for the individual usage. Sort of what goes along with that premise is the idea that I'm going to be versioning these services as well. So next year when I do an update, I'm not going to update those services in ArcGIS Online in place. I'm going to publish a new service. So like, for example, if we say what you find now, if you go to the Commons and you connect to the service, it says school programs in Minnesota for the school year ending in 2020. So school year 2019 to 2020. Next year, I'm not going to update that service in place. Next year, I'm going to keep that service in place. I'm going to create a new service. And then I'll let people know. I'll say, hey, the new service is available. Go start using that. If you want your stuff to look at the current stuff, go start using that. And I'll probably keep maybe 3 or 5 years worth of services up so people can move over time. And that way it's more like versioning against an API or something like that. It's a little bit different than what people have seen before where they could just set it and forget it. It puts more power, more responsibility, but also more power in the hands of the users who are either developing applications for this or just putting it into their ArcGIS projects or their QGIS projects or things like that. So those are things that I'm doing a little bit differently. That's the architecture I'm leveraging, and it's been a pretty good process so far.
I'd just like to ask a couple of questions about that architecture there and your use of ArcGIS Online. So oftentimes I've heard people say that it was really difficult to forecast the cost of using ArcGIS Online. And my understanding is that you pay per read and write. So I heard you say that these are not huge data sets, so I'm assuming that there's not going to be a massive amount of traffic there. Does that mean that you come under a certain read-write level where, the first 5, 10,000, whatever is are free, and then you start to pay? Is that why you don't really need to think about the budgeting side of this?
I have to be careful here because some of what we have available from Esri are from the enterprise license agreement we have in the state. So I can't reveal too many details around that. But I actually don't think it's too atypical that we actually don't pay or don't cost any credits for reads. I think that's pretty standard for their cloud offerings, that you do pay transaction costs or which credits, call them danger bucks if you want to call them or whatever. But you do pay transaction costs when you do an upload, and that hosting over time, depending on how much data is, you incur transaction costs for that hosting of that data. So you wouldn't want to load up, 100 gigabytes of data and then redo that every week, right? If you had to do that, that'd be ridiculous. It would just you'd incur lots and lots and lots of costs for ArcGIS Online. But if you've got a small data set like this and you upload it, once that upload is done, I'm paying less than a credit a month, I think, for the storage costs, and I'm not paying anything for the reads. So anyone that's consuming that and reading that from me, I'm not incurring any charges. Now, if I were editing it, so the read write, if I was doing transactions there and saying like every time I add a new school, I went in and did a transaction in ArcGIS Online, I would incur costs there. But I'm not. I'm saying this is a cut. This is a yearly report. Here it is. I'm doing all those updates internally on my own stuff what is on ArcGIS Online was the cut at that time of date when it was published, and that's it. And next year there'll be a new one.
Thanks for taking the time to answer that for me. I really appreciate your insights there. I had another question, and that question is, why did you decide that you'll publish these as separate services? I can see some different pros and cons around this, and I'm interested to hear your answer, because I think another way of doing this might just be to merge both those data sets and publish them, and then let people filter them themselves. But I'd be really interested to hear your views on that.
There's definitely different ways to do this, and my predecessor did have, like, I think, a single service with various different breakouts of these school programs, and I think a single service that had both district boundaries and attendance boundaries. I looked at it as, well, these are three separate resources on the geospatial commons. On the commons, a resource is a package of data. So there was already that sort of system laid out. The school programs themselves are pretty complex. There's a lot of different ways to filter and break out that data as well. It's not just all public schools in the state. For example, it includes private schools, it includes colleges, it includes libraries, adult learning programs, you name it. There's a lot of different programs that are in there, and there's classifications within that layer to further break that down. And sometimes people just care about that data. For example, that Department of Agriculture example I was telling you about earlier, they don't care what school district the spill is in, right? They don't care what the attendance boundary is for that area. They just care there's a vulnerable population nearby. Here's how we can find that vulnerable population is through school information. So that's a really complex layer that, to me, justifies publishing on its own for people that are really interested in that detail. And then the other two layers, to me, make sense to publish separately because they have their own sort of audiences and their own use cases that are a little bit simpler.
Yeah, and I think it's really important to have the audience in mind. Of course, when you're doing this kind of work, who is going to be using this? How can I best serve them? And it really feels like that's what you've done, and this is the reason why you've published different services in the way that you've done that. I think another really important thing about what we've been talking about so far is the fact that you couldn't choose your architecture. I mean, you had certain things in place already. You couldn't just rip all the data out of SQL Server and put it somewhere else because you, for whatever reason, want to use another kind of tool. So a lot of the building blocks for solving this problem, that they were set. You couldn't just change them around. And I think this is pretty typical when you're working with geospatial data. People will have their data in, the tools that they're used to using and the environments that they're used to using, and you just have to work around them. I just want to try and do a short sort of summary for the listeners so we're all up to date. So we had this problem. We had a certain amount of data that needs to be visible internally and externally. It was in different databases, and the architecture has already been decided for us, essentially. So we know that we're using an Esri environment, for example, and we know that Esri environment is pointing at data in Microsoft SQL databases. And you've decided to publish this data to ArcGIS Online for various different reasons that we talked about before. Can we move on now and talk a little bit about what you did in the database to make all this work together?
Yeah, absolutely. So as I mentioned, there's this organizational database that has been in place for a long time in SQL Server. And the districts themselves, the programs, and the administrators within the department have a number of rules, incentives, and maintenance routines to keep that data updated. So, for example, if a school district changes their website URL, they want to make sure that that's available and changed in there. If they have new contacts for a new principal or a new administrative assistant or something like that, they keep that in that database. But my predecessor would basically maintain a silo of just about all that data. And I just looked at that and said, well, there's a lot of demands on my time. I really am going to have a hard time keeping that sustainable. And that data is the source truth of that data is in that organizational database. I'll just join that. So I made sure that all the programs and all the attendance boundaries and all the district boundaries had the key identifier that was important for linking to that data. It's an internally managed identifier. So I did joins, essentially, taking the spatial data, starting with that, using the identifiers, and then pulling across from the organizational database just through inner joins primarily. but pulling in the URL, for example, why should I type in URLs and all the spatial data when it's already maintained over someplace else, right? So this is really fairly straightforward joins, fairly straightforward SQL. You talked about having to work with what you have in place, right? Most of my database experience before this job was in DB2 and PostgreSQL, but I couldn't just take all this data and shove it into PostgreSQL. That didn't make any sense either. It didn't make any sense to create a new silo. Many of the skills I learned querying those databases were very applicable to SQL Server. I just had to learn a few quirky syntax type things, which my IDE helps me with amazingly. And I was off and running. I could do those joins. I could do those selections. I could create data that was much more quality controlled because of those skills. And, going back to GeoHipster, I think one of my favorite recent interviews in particular was a local faculty, David Haynes, here at the University of Minnesota. He said, if you learn the back end, you're viable forever. And I've really found that to be true, and good advice for folks coming up in systems. Certainly, you can use Python and crazy ETL schemes and FME. And you can use all kinds of tools for moving data from one space to another. But in a lot of cases, I found that, when you take a database that's optimized for maintenance, that's not typically what the GIS end user wants. They want a flat file, right? And there's no way to design those, a database to meet both those needs. But you can design a database that's optimized for maintenance and then create SQL views or routines or things like that to spit out a report, to spit out a published data set that is really useful for users. And that's really, that power saves me a lot of time. And that's was kind of the primary thing that I did differently from my predecessor. And I really hope that at least a better quality data, and I could continue the tradition that he established of sharing this data every year and sharing it an accurate set that really draws on the strength of the organization and its core databases.
I really, really, really like what you said there about databases, and I hate to say it, but I really like your enthusiasm for it as well. Centralizing data, having it in one place, and having the documentation in the database itself. And when I talk about documentation, I talk about the views and the joins that you've made. They are in the database. Anyone can go in there and have a look, and you can update them one place, and that'll change the flow of data depending on how you do that. That'll change the filtering of the tables that you're exposing to the world. And I think this is, in terms of maintenance anyway, such a better solution than perhaps what some people might think of as automation. They might think of FME, and like that is a great tool, no question about it. Python is an amazing tool, but I think you can very quickly paint yourself into a corner when you start to build this web of systems around data and pulling it from different places and magically joining it together through Python or some other automation tool, and then spitting it out as flat files somewhere else that then get picked up by something else. I mean, it sounds to me like what you've built is going to be a lot easier to maintain in the long run.
Yeah, and I think it's important to make a distinction about the situations too. If you are someone that's aggregating data from, say, 20 different sources or something like that, lots of times you don't get to have direct access to those databases and those choices. So in those cases, Python or FME can make a huge difference. In my last job, one of the things that I was really proud of was inheriting a big Python code base, merging parcel data from 87 different counties in the state and running that. And I'm actually still doing that in my current job until my former organization is ready to take it over, which is probably going to be pretty soon. But that was a big Python exercise because we don't have access to those county databases. We don't have direct access to them. We have access to their open data sites, if there are any, or what they've provided to us individually as shapefiles. So that's a completely different scenario than the one I stepped into in my new job, where the organization has a lot of data that it is maintaining on its own, a source of truth. I don't have a really better word for it than that. But internal systems that they leverage, and all these different school districts throughout the state contribute to that database and report through it. And it's a structure that is in place that only makes sense to leverage. That the power of SQL to be able to help you and able to do that is almost endless.
I think what you're getting at there is that it's the tool depends on the job, right? It depends on the problem
Yeah.
that you're trying to solve. But I think it's really important to point out that you are still working. You inherited that Python code base, and you're still, even though you've left that organization now, you're still working on it because it's a critical piece of infrastructure. And sometimes you can't just hand it over. But I'm willing to bet that the person who takes over from you, if you move on one day from your current position, they will have a much easier job taking over and maintaining what you've built here. When we talk about the work you've done with Microsoft SQL.
Yeah, and I really liked what you said about sort of the documentation, right? That's the great thing about code is that whether we're talking about that Python set or the views that I'm building for these spatial data joins and so on, is that code is replicable, right? It's readable. Someone can look at it, and if they're skilled in Python, they can read through it. And there's lots of great comments in that code base, which is good. That's huge. Self-documenting information. So instead of having to take screenshots of 20 button clicks that you had to put together, you've got comments in your code that says this is what this does, and if it breaks this way, here's how you go fix it. So and the same with SQL. Every view that I build, I came to the space, and two high quality DBAs were there for me to ask questions of, and to say, hey, I'm gonna build a view to get this job done. What are the conventions you guys have for this? And they said, here you go. Yeah, here's the naming convention, and here's a sample thing. Here's where we put our comments. Here's where we put dates of when it was created, who created it, modification lists, and so on. And it's all there in the view. I believe the database stores most of those comments. If it's not, it's in our code repository. But it's all there to be able to say, like, this is why we did this. This is how it's done, and this is where you go get those structures and what it accomplishes. So it's replicable, and someone can come in and say, oh, okay, all right, well, oh, there's a new view now, or there's a new table, or there's a new tagging structure in the database that I need to leverage. I got to make this tweak to add this tag in order to get this done, and move on. And yeah, that's to me one of the biggest appeals of coding, wherever you're coding, is the repeatability of it, to make it almost scientific, to be able to say, like, yeah, we can do this again if we need to change it.
Yeah, and I am completely there with you. I'm 100% there with you. I would just like to highlight what you said about documentation again. I don't believe there's any code out there that's self-documenting. I think people need to write instructions. I did this. But you made an incredibly important point there. A lot of big organizations, or organizations in general, where people are working together as teams, they have certain ways of doing things. They have certain ways of writing code. They put them in certain folders, in certain structures, and documentation looks like this. And that's something people don't really talk about, but that is a huge part of making systems that are able to be maintained and that are understandable by other people as following that standard set out by the team you're working with or the organization you're working in.
Yeah, I think that is really big, and no place is perfect with documentation. You're right. There's no code that's perfectly self-documenting. You really have to be deliberate about writing in comments and so on. And the place I'm in now, it's funny. There's some very good standards in place in some spots, and not so good standards in other spots, or lack of standards in other spots. So no place is perfect with that. So when somebody comes and joins something new, I do recommend that they try to find those conventions where they exist, but don't get hamstrung. Don't get completely blocked if there's no standard, right? Because no place is perfect at this. No place is 100% regimented and routine, where everything's written down and everything is fully understood by everybody in the place, and there's constantly updating GitHub repos with things that are changing. At least I haven't found that place yet. I'm sure there's some really well-run organizations that get that to the 80%, right? But in my experience, typical organizations, sort of medium to large size bureaucracies in a lot of cases, it's more like 50%, right? So we've got good conventions around 50% of our work, and the rest is, unwritten rules, verbal notes, or no convention at all. And you kind of have to blaze a trail and make things up on your own. And so that's out there, and that's part of the challenge of technical work is figuring out how those things fit. But yes, when the conventions exist, it's tremendous. I mean, if some kind of major disaster happened to all the tech people in my organization and somebody else had to come in, they would find quite a bit of conventions in terms of database work and documentation and code repositories to be able to pick up and say and discover patterns and pick up where we left off, because that just makes things it's the grease that makes the gears turn, and it keeps them turning.
Completely agree. I think structure is really important. I don't think any organization or team has the perfect structure, and I think there's always room for improvement. And I think if you're starting at a new organization, one of the things you can, I mean, it's important to take the time to learn the understandings that team has. Okay, we do things like this, and then I think once you've been there for a little while, I think it's really important to start questioning things as well. So why are we doing it like this? Could we do it like this? Could it be better if we do it like this? And oftentimes organizations that have been doing the same thing for a long time, they haven't thought about those things for a long time either, and they just do it because that's the thing we've always done. It's not necessarily the best way of doing it.
Yeah, absolutely. That's a really bad situation to get stuck in, where the only every time you ask why or somebody asks why, the answer is this is the way we've always done it. Right? That's always a blocker for innovation, for creativity, for progress. In contrast, going back to those database views and the DBA that show me those pieces, I looked at what he gave us. The naming convention is very simple, just UVW in the beginning. So it's just a short prefix, and then I could do what I wanted with the rest. And the rest of the convention was just laying out sort of the series of how you construct a view and where the comments were put at. And so when I looked at that, I didn't have to ask why. I looked at that and said, that makes perfect sense. It's not overly onerous. It's not especially difficult for me to comply with. And I see the space where I get to put in my notes for myself and for anyone coming after me. And so it's the perfect kind of standard. Anything, it's not really even a standard. It's a guideline, right? It's a convention. So if you build conventions like that give people some basic structures to work with, some basic guidance on where to go, but aren't overly restrictive, it can really set yourself up well for your future work.
Mike, I'd like to shift gears a little bit now and sort of talk about the tools that you used and why you used them. So I think we mentioned earlier that the tools you used, that was kind of dictated. That was a given. You were in this certain environment, so you used those tools there. Could you sort of briefly describe what your ideal situation might look like as a given your skills, and if you had a complete blank slate to start from? How would you put this architecture together?
Right. That's kind of two different questions. Blank slate, how I would put the architecture together compared to my skills, because my skills actually go against how I would start from a blank slate. Because primarily for cost and looking out for being a steward of the public trust and of public funds. If I were starting with a blank slate, I would start for this situation. I would start with PostgreSQL database. I would start with PostGIS, and I would manage that data with QGIS. Even though I don't have as high skills in QGIS as I do in some of the Esri spaces, I know that it works really well with PostgreSQL and PostGIS, and I know it's got plugins for things like QGIS to GeoServer, so I can publish into that space in that stack, and I can spit out shape files and I can spit out geo packages for publishing. So if I were starting for a blank slate, that's what I would have done. But again, yeah, we are. I'm not starting with that. I come in and SQL Server, kind of a new space for me, but didn't take me too long to pick up the ArcGIS tools. So the Esri Suite, ArcGIS Desktop, and ArcGIS Pro both interface well with SQL Server. Same with ArcGIS Server. ArcGIS Online, really just a cut there. I did use ArcGIS Desktop primarily for this. I definitely have 20 years of experience, on that hill, and it's hard to get off of that hill. It's really easy for me with all of its quirks and warts, ArcGIS Desktop, I'm extremely familiar with that platform, and I can manage data up the wazoo. It's got everything I need for managing that data there. I'm not as familiar with ArcGIS Pro. I'm probably going to start moving into that space in the next few years, but I'm also going to start trying to use QGIS for certain tasks, because the less I use the Esri products, the easier it is for me to be able to justify moving off them in the long run, and diversifying the stack and being able to say things like, if I lose access to ArcGIS Pro or something like that, or if I have too few licenses, I have an alternative. I can leverage there. So there's definitely a little bit of a disconnect for me in terms of how I would start if I were starting from scratch versus what my skills are. Luckily for me in this situation, really only having to learn one sort of new space in the stack made it a lot easier for me to up and running. If I had come into the space and didn't know anything about ArcGIS Desktop or ArcGIS Server, I probably would have struggled a lot more.
There's a couple of things I'd really like to highlight there for the listeners, and that's firstly how easy it would be to create this stack from open source. So Postgres, PostGIS, QGIS, interfacing with that, and distributing data through GeoServer, done. All open source tools, tested, stable, amazing, and anyone can do this. So I really just wanted to highlight that for the listeners. Another thing I heard you say, which I think is equally as important, is that idea of diversification. You know a lot. You understand how to use a lot of different tools, and therefore you can easily come into a new situation, a new environment, and quickly understand how things work, how they fit together, and get up and running with them. And I think that understanding, that really helps you out. If you've worked in ArcGIS for a long time, of course you can take that conceptual understanding of what tools are doing in the background, but I think it's really important to and go over into something in QGIS, for example, but I think it's really important to have that sort of hands-on experience of using different tools, understanding how they work. And then when you approach a blank slate, you can say, oh, well, I know that this particular tool will function really well here. This is, with this pros and cons, I can put together this stack here. And I think that diversification, understanding different tools, how they work, what they're good at, what they're bad at, I think that's really, really important.
Yeah, it is. It is. And, really as technologists, we have to be ready to learn new things and to take on new tools and to figure out what the situations are when we get there. When a carpenter shows up to a work site, they're not just bringing their hammer. They've got other tools that they use to get the job done. And sometimes they're going to be given tools by the work site, by the customer, to say, here's what we have available to do this work. So I think that's really important. One tool I didn't mention is my favorite new tool of the last 3 or 4 years or so, Microsoft's Visual Studio Code. It's a free IDE essentially for writing code, and I've used it to write and maintain SQL, Python, HTML, CSS, JavaScript, just about everything that I need to do. I don't think it. Well, I'm sure it can be done. I know it can be used to write things like backend scripts like Node and things like that, and I think it can be used for code compiling like C# and Java, but I haven't seen it as much. It's not quite that in depth of an IDE, but for scripting and SQL, it's great. I got that installed on my machine when I got to the space, and I connected to the SQL Server, and there I could browse the database right inside Visual Studio Code. And that was tremendous to be able to browse the database and see where the tables are, see where the views are, see what the columns are within those views, write some queries and understand how that data was there. It's a really good tool, and that's one that I've learned in the last few years. It's not something that I was familiar with 10 years ago. It's not like ArcGIS for me. So yeah, having a suite of tools that you can use that you're always learning is a great way to get your job done.
And a tool like that, which can be applied to lots of different kinds of code, I mean, that's fantastic. Instead of sort of hopping from one environment to another environment, depending on which language you're using, I mean, you can save so much time with that.
Definitely.
One of my final questions for you is now that we've been through the case study, we've talked about what the problem was, and we talked about how you solved it and the tools and the architecture involved in that. I wonder, when you're looking back on this, is there anything that you would have done or could have done differently?
Yeah, definitely. There's a few things. One of the things we haven't really talked about is the spatial SQL, right? SQL Server and a lot of these enterprise databases have spatial functions in them for interacting with geometry, and that's tremendously powerful. For example, with each of these school programs, right? If it's in district, if a school program is in district X, right? If it's a public school, it's probably operated by that district, right? But if it's not a public school, or even if it's public but not sort of directly connected to that district, it might not be operated by that district. But lots of people want to know, what district is it in? What county is it in? Right? And that's point and poly lookups, right? So you can do that in ArcGIS with an overlay and make a cut. I didn't do that. Instead, I leveraged that power within SQL Server to do those lookups directly, to be able to say, like, okay, I'm going to derive the county column based on the spatial information of that program and the counties that are out there. I'm going to derive the school district that it's in column. That's a separate column from the organization that runs it sometimes. But I'm going to derive that with spatial lookups and spatial queries. So that's what I did this first time around. I'm going to double down on that next time. Next time, I'm going to take it even further. And for example, those attendance boundaries, that's the core boundary maintenance that I do is around those attendance boundaries. And those are nested inside the districts. So instead of manually dissolving those attendance boundaries into a separate layer of districts, I'm probably going to try to derive full districts by live merging those attendance boundaries with spatial SQL functions, which I already know are capable. I already have them working in views, and I'm probably going to do that next time to make those reports. So I'm going to do that through spatial functions. It's going to save me one more step. I'm also working with one of the main developers on the organizational database. We've talked about this. We've agreed on the approach. We just haven't executed it. But I want to sync up more so that when address changes take place in that database, that I get a notification so that I can manage on the geospatial side. And they have long columns in the organizational database, but they're not really being maintained. And so we want to sync those two things up so that that organizational database is the source of truth for everything except for spatial. And my database is the source of truth for the spatial pieces. So sync those two up so that when I make a change on the spatial side, the lat long gets updated on the organizational side. And that'll open up the door to making other spatial information sort of reporting even more accurate. For example, the reporting pieces on that database it contains counties and it contains legislative district. And those things, because those lat longs aren't really being maintained very well, those things are slowly getting out of date. And we're going to face a big redistricting in the next year or so. And so we're going to have to redo all that stuff. So my goal is by that time to have the spatial side synced up with the organizational side constantly so we get more accuracy in the long run. And the last thing I'm probably going to do is my predecessor really did some manual manipulations to classify individual school programs as elementary school versus middle school versus this is where the district office is and this is the type of library it is. And I'm going to try to align those more with the internal standards. So I'm going to align those classifications a little bit differently. That's going to take some time for the users to get used to, but that's going to make for better maintenance over time as well. So three things really: double down on the spatial SQL, sync up more with the organizational database, and adjust the classifications.
I'd just like to dive into those updates that you mentioned there, because you mentioned updating data based on actions taken on the database itself, and you mentioned notifications. Now, for me, I'm immediately thinking trigger. Is that what you're using? Are you going to trigger a notification, an SQL trigger, I should say? Is that going to be fired every time an update happens and send you a notification, or what mechanism are you going to use to update that data and to send those notifications?
I'm not entirely sure. It'll probably be triggers. The developer who maintains the tech side of that database is likely going to be the one to execute that. So he knows the end goal, and he'll figure out how to do that for us. Luckily for us, we're talking 5,000 or so active programs in the state, right? And so there's maybe 20 or 30 address changes in the database, a month, right? So it might be even a week, right? But that's the scale we're talking about. We're not talking about thousands of changes a day, thank goodness, right? So that scale is important to remember, though, because if it were thousands of changes a day, then this this idea of what I have for getting those notifications just wouldn't work, right? But what we'll do is he'll generate, probably through triggers or something, probably a daily report for me that says, here's the address changes, here's the organizational IDs and the names, and the address changes that were recorded in the database over the last day or the last week or something like that. And I'll look at those, and I'm anticipating that it'll say old address, new address, and I'll be able to quickly glance at that and say, oh, well, in that case, they fixed a typo. In that case, they just added a suite, right? In that case, they added, they didn't have a nice address. They didn't say County Road B West. They said County Road B, and they should have said County Road B West. So they added the West. Okay, in that case, I don't really have to make a change, right? But if I see that the house number has changed or the house number in the street has changed, I can say, okay, that means this program moved. This is, or a lot, probably more frequent cases will be, here's a new program, here's a brand new program that I need to be on top of, or here's a program that's no longer active. So those will be additional notifications I'll have to get. So I think that he probably will use database triggers. I do know that those components are already audited on his side of the database. So he has a log of those changes. So that's probably what the triggers do is keep those logs updated. And he's probably just going to report those logs to me on a daily or weekly basis.
Hey, Mike, I really want to thank you for coming along today and sharing this case study with us. My hope with this is that someone out there will listen to this one day and go, wow, okay, here is someone who's showing their work. Here is someone who's brave enough to say, I did this. It might not necessarily be the absolute perfect way of doing it, but this was my approach, and then we can all learn from that. So I really appreciate your time. Before I let you go, where can we go to reach out to you if we have questions or want to get in contact with you?
If you're someone that's more interested in sort of, I want to develop myself professionally, I want to learn more about this stuff, I definitely recommend that David Haynes interview on geohipster.com or any interview there. Really good insights into unique people in the industry. And then my Twitter handle at MMDOL. BOW. You can tweet at me. I usually return and reply to those tweets. My DMs are open there. Certainly get in touch with me through that or through the GeoHipster Twitter account. Either of those are good ways to get in touch with me. I really appreciate this opportunity to talk about this stuff. I really think it touches on a lot of things that I care about, being able to leverage databases and understand the power there, publishing data, sharing data with folks, and sharing our expertise. I really hope that this episode has helped people get an insight into how I've done my work and how they might be able to solve a similar problem in the future.
Thanks again, Mike, and I'll be sure to link to all those sources that you mentioned, all those different ways of getting in contact with you, and of course that first interview that we published back in November of 2019, just so people can perhaps learn a little bit more about you and get a little bit more background. Thanks again. Much appreciated.
All right. Thank you. Take care.
So thanks again to our sponsor, OpenCageData. And I think that this really sums up OpenCageData. When you go to the website, under the frequently asked questions, there's two questions there that I think are really interesting. One is, do you make maps? And the answer is no. And the other question is, do you provide a routing service? And the answer is no. What they do, though, is provide an amazing geocoder, and they do it really well. So they're a company that's focused on geocoding, and they offer incredible service, and I can highly recommend these guys. If you have any geocoding needs, check out OpenCageData. And that's it for another episode of the Mapscaping Podcast. My name is Daniel, and I want to say a big thanks for everyone who's tuned in again this week. It's much appreciated. If you could do me a huge favor, please share this podcast with a friend or someone you think might enjoy it. It helps the show grow. It helps us reach more people. It helps us spread the word about geospatial. I would really, really appreciate that. If you haven't subscribed, consider doing that. I've got a whole bunch more great guests lined up for you. And yeah, I look forward to bringing you more interesting stories from the geospatial world. As always, you are more than welcome to reach out to me on social media. You'll find me at Mapscaping on Twitter, Mapscaping on Facebook, and map_view on Instagram. I really look forward to hearing from you. Okay, that's it from me. We'll talk again next week. Bye.